So do you guys notice anything, any sort of relationship between kind of like, we'll continue to use this terminology of inventory. Okay, do you guys notice any like patterns between your inventory of like what you have on the left side, right? How many of each, and then the sort of numbers that end up appearing on the other side? That's my question, right? So by that I mean, like, can you see any sort of relationships that exist between that whole piece and your inventory from the left? If I had to write down a notice, and I'm trying to think from your guys' standpoint of seeing this for the first time, I notice, well, I see that there's two, like, remember what I said about this? This means that there's an x times an x. I could condense that down, right? Well, if I look at the other side, I notice that there are two x's there, right? Why? Okay. All right. Anybody else? Remember, it's not just about the first question. You're going to see the same sort of notices between this one and all of these sides, right? Right, and these are the questions we just finished doing too, from above. Okay, that's just one of my notices. Okay, it might not even have any wonders. I don't know. That's up to you guys. That's kind of tough for me to come up to. But I also notice, here's some of my other notices, which is kind of cool. I noticed that, conveniently, there's like a 2 and a 3 here, right? I see some relationships between the 2 and the 3 and the 5 and the 6. For one, it looks like, okay, well, 2 plus 3 equals 5. That's kind of interesting. But also, if I took 3 times 2, that's equal to 6. That's really interesting. It's kind of like a special, like, these two numbers are special from the standpoint of this equation, right? And if we go down the page, 1 plus 2 equals 3. 1 times 2 equals 2. 2 plus 2 equals 4. And 2 times 2 equals 4 as well. That's kind of interesting. So what if we could have a way to represent this in terms of math? That's kind of where we're headed, right? It's like this rule that's coming up here. We're just starting to try and like develop a rule, right? With these two, like, we're seeing this pattern. The rule comes out of the pattern. We've used those two words interchangeably before too, right? So if I scroll down here, so I'm noticing that the numbers in green are special. And I suppose your wonder for that could be, how do they relate to the other side? Okay. We showed you kind of how they relate. Okay, we're just going to want to kind of come up with a rule. Okay, so let's come down. I'm going to try and build this one okay? But I'm going to show you something else this time. Okay? This time, and this is, I'm going to try and pull you away from the tiles a little bit, okay? Because you don't want to sit there and do that all the time, right? If we need to a couple times today or over the course of like your homework, you can build them, okay? This is kind of the method that I think you're probably going to want to use. So let's look at, if you guys recall, I'm just going to write something else here unrelated because it's kind of an aside. And I'm just bringing your attention back to something that we've already done before. When I asked you guys 12 times 15, we drew a table, right? Where we're like, okay, well, I'm going to have 10 and 2, and I'm going to multiply, I'm multiplying, right? So down, this is your top of what we call the table, right? And then down the other side, I put 10 times 15. Okay, I called this at school, I called this an area at school. An area. Okay, and I've strategically shown you this for the purposes of what we're doing right now. So although this may have seemed redundant at the time and kind of silly, I showed it to you for a reason. Okay, we found that in order to fill out the area, we had to take the length and multiply by the width. Well, the length and width are the side lengths appropriately. Length and width, right? So when we multiply the length and width together, that's how we fill out the middle section, right? So to fill out the middle section, we went 10 times 10 is 100. 10 times 2 was 20. 15 times 10 is 150. And then 15 times 2 was 30. And then to figure out what our answer was, we just added up what was inside the area. Right? So we went 100 plus 150 plus 20 plus 30. 0, 8, 10. I should have written this neater. It's 300. Okay? Hopefully everybody recalls that, because it's going to rear its face here in a second. Okay? The opposite would have been had I provided you with the area, which is what I'm going to do this time. Okay? So for instance, had I asked you, what's 300? Can you tell me a length and width that gives me 300? Right? That's what it would ask. You would have built the inside. You would have built this inside section, which is a little tougher to do. Right? But when I tell you a little bit more explicitly what that is, it's a little bit easier actually. Okay? So we're going to look at what to do here. So I'm going to build this with the table. Okay? So I'm going to go, okay, x squared and 8. Okay, I've got a little table. Okay. The problem is, I don't know what goes here and what goes here. Okay. Oh, hey Leo. Okay. So I don't know if the table is the best way to do this, right? Because I don't know what goes in these two spots. But we did just figure out earlier, if I were to build this with my squares, right? If I took an inventory and we talked about, if I took your inventory and you said, okay, well, there's 1x squared and 6x's, and then 8 single squares. We could try and come up with what these two special numbers are. Okay? So if we come down here and we try and build this thing, we can have an x squared, right? Then we need 6 x's. I don't think that's going to work, because that leaves 9 singles. Okay, but this might work. If we erase it there and we put another one over here, then I got 1, 2, 3, 4, 5, 6, 7, 8 singles. That takes care of all of these, right? And then your job is, okay, well, how do I find this relationship, right? Like, where these two numbers like magically come from? Well, you need two numbers, remember, that looked like they added to this one, right? But then they also multiplied to that one. That's kind of the pattern that we saw above, right? Well, it turns out that those two numbers are what happened when you write these here. I'm going to do a different color. Those two numbers are the two numbers that are present right here. So if I was to write my length and width, I'm going to see that there are something here, x and an x, plus something, right? I'm going to see, okay, well, it's plus 4 there. That's plus 2 there. So what you guys are trying to prove to me is whether or not 4 and 2 are your magic numbers. Do they satisfy the fact that 4 times 2 has to equal 8? Well, it does. That's good. And 4 plus 2 equals 6. So that's good too. Right? That's where they're coming from. And what you're doing is you're trying to represent that as an area. Okay, which is actually, it's good that I showed you this, because we saw how if I just told you what the area was, right, like 300, that's a hard concept. Like, that's hard to do, because there's a few, I suppose there might be a few different answers to get to 300, right? There's no necessarily, if I was to build an area of 300, that's kind of hard to come up with what the length and width are. You could have a couple of different answers, right? Same thing's true here. If I just ask you to write the area out inside of a table like this, that's tough. There's a way to do it, right? It's tough. Okay, so here's what happens. Okay, as soon as you find these two things, there's your length and there's your width. These two things then become x squared plus 6x plus 8 is equal to x plus 2 times x plus 4. Okay, does anybody have any questions? Try to break that down in a way that I'm trying my best to pull on everything that we've done. There's a couple of hiccups in there, but that comes from just working with everything that we've done. Okay. Now you're probably all still sitting there and going, I don't want to do this 10 times. Okay, I don't want to draw these things. I don't want to build them. I don't want to build them with something, or like the tiles, right? You want a faster way. The faster way is finding or answering the question that we asked up here. If we can answer how these two things are related, which we already showed, right? We showed how they're related. These two numbers on the ends, they add to the here and they multiply to the number on the end. We can answer that question. then we're good to go. Okay, so let's try and do this one. But this time, instead of just building the area, why don't you try and actually tackle this in a way that you find two numbers that add to 6 and multiply to 9. Okay, and so what I like to do is I always kind of like doing this. Find two numbers that multiply, find two numbers that add, and then you tell me what those two numbers are down here at the bottom. Okay, so we need numbers to multiply to 9, add to 6. You tell me what those two numbers are. Okay, that's your goal. This is the fast way of doing this, which is how I want you guys to do it. Okay. Do we have any questions? You can type them in the chat there. Remember what we're trying to do. We're trying to write this thing into its length and width, like from the table. Okay. Here, you guys can see this. I'll pull this up again. Okay. What I'll do here is I'll just build this. Okay. I'll get rid of these for a sec. We look at our inventory, right? It's telling us we want. You can't see it. A sec. And this is maybe the thought process you guys are going through, right? Is you're thinking, okay, build it with the area first, okay, and then figure out. Check your answer using this method. I think that maybe is the way to do it right now, right? Build it, get some experience building these things, check your answers with this man method. Okay, so if I throw in a couple more rods here, okay, because I remember what I need 6 of those rods. I only see 4 in our picture right now. Okay, so if I add 2 more, okay, like say there for instance, and then I need 9. I'm gonna need 5 more orange ones. Well, if I go to here again, I'm only going to be able to throw 8 there. So I'm going to have to shuffle my area, right? So let's bring it up there. It looks a little bit better. I can't have these two floating because they're nowhere, right? So I got to bring them up here. And there you go. So conveniently, if you look at this question, I've now created this perfect square or a perfect rectangle, right? That is a square, right? And if I were to look at the pieces, I'm going to have x plus 3, and I'm going to have x plus 3, right? So if I built it, there's your x 1, 2, 3, okay? And then there's your x, oops, I'll go across the top, x 1, 2, 3. Okay, so the length and width, you know what kind of the answer is now, right? You're going to say x plus 3 is the length, and then you're going to multiply that against x plus 3, right? So you can see now, as we start to like build these areas and come up with the length and width, you can see conveniently, well, it looks like 3 and 3 are kind of the magic numbers that satisfy this condition. Right? 3 times 3 is 9. 3 plus 3 equals 6. So instead of having to do this runaround of building the area all the time, because I'm going to give you, I don't know, might give you 4 of these questions on a test, right? You don't have to build these all the time. Why can't we just do a little bit of thinking around these two numbers, which come from here and here, and find the two numbers that work, right? So you're going to see, okay, well, that's fine. As soon as you get these two numbers, you just go x plus 3 times x plus 3, and you're done. You get the same result. Okay, does anybody have any questions? So, how about we do a couple of these? Okay. I'm going to build them with the rectangle again. Okay. These ones are a little bit different. Okay. We don't need our x squared anymore because that's kind of gone. Okay. We're going to have x. I need 2 of these x's, and I need 4 singles. Okay, and the rest can go away. So I get 2 x's, and then I could probably just slot these. Again, you want to create this perfect rectangle, right? So I could probably just slot these in here underneath and be done. Okay, now, same thing applies here, though. Tell me what to read off. Well, it looks like, okay, I could go x and 2, 1, 2. Then I could also go, okay, well, what's my width, though? How wide is it? Well, I could put a 2 across the top, right? And so my length and width for this scenario, or to draw this, like what I've built here, I'll draw what I built. We got 2 rods, right? Because it's 2 rods, and then 4 singles. Right? And then you tell me, okay, well, how do I read off the sides? What's this side? Well, it's an x from here to here, and then plus 1 plus 1 is 2. And across the top, I could fit 2 1s, so that's just 2. And so the length and width for this one is 2 times x plus 2. Okay, same thing if I built, if I decided to go like this. 3 x's, you gotta create a perfect rectangle, plus 3. Oh, what are the length and width? It looks like I fit 3 singles up top and an x down here and there. All right, well, if I drew this one then, I'm just going to redraw it. I got 3 x's, so 3 rods, and then 3 singles. Right? So if I wrote my length and width, this is an x, that's a 1, so x plus 1, and then also 3 across the top. I could fit 3 singles, 1, 2, 3. So 3. So my answer is going to be 3 times x plus 1. Does anybody see what's going on? This is a kind of a, this is building area models. It's the exact same thing. It's just a little bit different this time from the standpoint that I don't have any of these big squares, right? They don't exist in these questions. So they're a little bit easier. Okay? But can somebody tell me what's going on here, right? Like if I, and again, I'm just asking you to look for a relationship between what you see here and what you see down here. What you see here, what you see down here. Right? So if I were to move all this, based on what I've done here, and if I were to look at these a little bit more closely, it looks like, based on my answer, if I looked at what was common between both of these, what's something in common between both of them numerically? We can do that one after, actually. Okay, just look at the first one for now. It looks like if I look at both those pieces, I've got two pieces here, right? It looks like both those pieces could be divided by 2. Well, that's interesting. So what happens? So if I divide both of them by 2, I'm going to get 2 times. If I divide both of them by 2, I got to write the 2 out front and then tell me what's left after I've divided by 2, right? Because I can't just cancel things. If I decide to divide by 2, I also have to multiply by 2, right?
Ethan has a comment in the chat.
Yes, Ethan. Let's look. Yeah, okay, so Ethan, any of this stuff, these rods of 10 are going to be an x. Okay, when you look at these questions, this just means that there are 3 of them. Okay, and then Ethan, they're really close in relationship. They're a little bit closer in the sense that, like, if you looked at a rod, one of the squares, it's an x squared. It's an x squared because it's comprised of an x and an x. Now its relationship to numerics, or like a numerical value, is if I rerun, this is just all, I should do this on a separate spot, but relation to, if I looked at actually how many squares existed in this thing, it was 100. Well, how do I get 100 squares? How do I get 100? Well, I take 10 and multiply it by 10. The 2 rods, which we said were x and x. We're just changing the values. Okay, x squared from 10, 10, 100. Okay. Okay, the algebra tiles move away from kind of, they're not just number things and counting techniques. There's some algebra built into them, or at least the foundations or the concrete version of algebra is built into these things. All we have to do is change their name, right? What each of them stand for, right? So that's all we're doing. We've changed the squares to x squares. That's why they're called x squares, and the rods are x's, and then the little individual ones, the little squares, are going to be the numbers, just numbers. They're just counting. Okay, so a whole bunch of stuff on here. I'm going to get rid of some stuff here. Okay, so if I get back to this, I can't just decide to divide by 2. That's not allowed, right? You can't just decide to do something. But if you divide by 2, like what I did there, you can also multiply by 2 and you haven't changed anything. Because what is 2 divided by 2? Go to 1. So you haven't changed anything, right? So that being said, if we do that, then I write the 2 out front, and you tell me what's left on the inside of these brackets after you divide by 2. 2 divided by 2 is going to be 1, but you still have the x there, so 1x. 4 divided by 2 is 2. And you guys confirm that that is that answer. Okay, so I'm just looking to what could I divide both of these by. Most of the time it's the thing that's out front. Okay, if I'm probably going to give you questions that look like this. And the question will say, okay, simplify or something. Simplify means just make it look a little bit easier, right? The chances are it's just look at this and say, okay, I know I can divide both these by 3. When I do that, I have to write the 3 out front, and then you tell me what's left after I do that. 3 divided by 3 is 1x. 3 divided by 3 is plus 1. And you guys can again confirm that should be the answer that we found down here after we built the tiles. So again, it all comes back to living in this concrete building of things, right? You can always build these with tiles. You can always draw the pictures and figure it out. But there are faster ways. The faster ways are the ways that it typically gets taught, right? Just right out of the gate. And then students are lost. We don't know what to do, right? Because it's just it's like magic. It's smoke and curtains. We don't show you this, the tiles and building things or drawings, right? Like all these drawings are like the behind the curtains of the magic. So if you spend a little bit of time there, you can figure out what's going on. And all of a sudden, this is no longer such a stretch. Like what's going on there, right? Because you're arriving at the same answer. But a lot of the time what ends up happening is we just decide to do this, right? And then we're like, okay, next question, and nobody understands what's going on. Like physically, there's no concrete understanding going on. And what's tough about doing this online here is that you guys don't have the opportunity to actually build these things in front of you, and I can't tell who's struggling and who isn't. Especially when you guys don't type any questions, right? I can't tell. So the flow here is a little bit rough just from the standpoint that I can't tell who's where and who's struggling. Okay. And also, I haven't seen you build it, so I don't know how to take you further. Okay, but I'm just trying to sprinkle in, for those of you that might be a little bit ahead, sprinkle in like kind of the shortcuts. And also, for those of you a bit behind, building in the concrete. Okay. From the standpoint that if you guys need to spend a little bit more time building these things and working with them, then you can do that and eventually end up to the shortcut. I think a lot of the time the shortcut just gets shown and then we lose half the kids, right? So it's okay to spend some time here, right? So for the last one, again, I'm just going to say like simplify this, right? Make it look easier. I look at that and I go, okay, well, I got 2 things there, 1 and 2. How are they related? Well, it looks like I can divide both of them by 5, right? Well, I can't just decide to divide it by 5, right? And that's it, because that changes the equation, right? So the only way I can do that is if I divide both these by 5, I got to multiply by 5 as well. So I'm going to write the 5, and then you're going to write, okay, well, 5 divided by 5, x minus 10 divided by 5, and just do the math here. This is the shortcut. Spelled out very well, I think. Okay? So you're like, okay, well, just do the math. Well, it's 5. You can't just make that disappear. 5 divided by 5 is 1x. Minus 10 divided by 5 is 2. There's your answer. And you're done. Okay? When we come back this afternoon, you guys are kind of in the practice area anyway. Okay, when you come back this afternoon, I want you guys to go down. Maybe try a couple. Go down to slide 27 and try a couple of these. Except you can't do the expand yet. I'm going to show you that this afternoon. Okay. Actually, you know what? Let's just hold off on the work. We'll finish this, and then I'll give you work that you guys can do this afternoon. Okay. So that's it. Okay, just come back at 1 o'clock. For those of you that don't have the test in, please do that. If I've asked you, or if you've left the graphs blank, send me some pictures of the graphs. If you weren't happy with your substitution question, sit down, watch a video, submit me something. Don't leave those blank. And do not just write me an answer either. Do not just say, okay, it's 5 and 18 or whatever it was. I can't remember what it was. 20. And say blah, 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 blah. Just words. Okay, I don't want to see that. I want to see your steps. So sit down, watch the video, and try and follow those 5 steps. Because there's questions that are identical. They're identical questions. You just copy it verbatim and change where the numbers go. Okay? But if you guys take the time to sit down and actually work through the steps, then I at least know you've done something. Okay? So go do that for next little bit. Because I know there's a few people with just blank, not blank substitution questions, like the very last one. Go work on that. Okay, that could be your work for now. And when you come back this afternoon, we'll finish this up and you'll have some questions for homework, okay? That's probably the best way to do it.